Good morning or good afternoon or even good evening if that's when you're working on this. Start Stallions. If you'll have seen, this week is all about patterns, graphing, input, outputs, so on and so forth. So that is what we are going to kind of look at today with our notes. So go ahead and grab that journal or just a piece of paper to work on. Again, make sure you're saving these notes. These are just like our journals that we do at school. They're going to be a fantastic resource to take with you to 6th grade to help you out. So go ahead and get that page and title it Graphing on Grids. Graphing on grids. We'll zoom into the top portion of this one while we work on it. Graphing on grids. So the first thing that we are going to do is we're going to create a coordinate grid. It's going to be a little annoying. I know. It's not going to be perfect, but we're just going to get out of the way. So we're going to title... Make sure, or not title, we're going to label what it is, a coordinate grid. And a coordinate grid is just what you've already seen before. It's where we have a vertical axis that meets a horizontal axis, and putting them together, you create a grid with a bunch of lines through it. We'll add our lines in just a second. I just want to touch on one thing about next year, because right now we're only dealing with this quadrant of the coordinate grid, okay? This quadrant is actually called quadrant 1. But I want you to know that there are other quadrants. See, those number lines, they don't stop right at that right angle. They keep going in the other directions. So this x-axis keeps going this way forever, and this y-axis keeps going this way forever. So what you have is you end up with 4 separate quadrants. This is quadrant 1 with all positive numbers. This is quadrant 2 over here. Down here you would have quadrant 3. And over here you would have quadrant 4. Now the reason that we don't delve into the 3 other quadrants is because all 3 of those quadrants end up dealing with negative numbers, which we haven't really gone into yet. So that's why we haven't gone over here yet. We haven't gone into these quadrants because there's negative numbers in those quadrants. But you'll definitely dive into that next year, okay? So let's just focus on quadrant 1, the quadrant that we're going to be working in with our positive numbers. We're going to go ahead and add some lines. This is going to be that annoying part. We're going to add some lines. Just try to equally space it apart as much as you can, because we're going to create our coordinate grid. Usually we would just print this stuff, right? But I'm assuming, like myself, not all of you guys have printers, at least printers that like have ink in them. So we can do this the old-fashioned way. So I draw some vertical lines on the x-axis, and now I'll go over to the y-axis. Now the y-axis is going to be easier because if you use lined paper, you can just follow the lines that are already on it. I try not to get my palm in the ink. You can see I've already started spreading it a little bit. Almost done. Again, this doesn't need to be perfect. Just needs to kind of give you the, general idea of what you're doing. Hey, it looks like a coordinate grid, right? Let's go ahead and label our axes. This is the x-axis. The x-axis, it's horizontal. I've talked about my kids, how I remember what the word horizontal means, that it goes, side to side, is I think of the horizon, where the, the sun meets the edge of the earth. You can really see it if you're looking out at the ocean. You see that flat line where the ocean meets the sky. That's what the horizon is. And then over here, this is the y-axis. And that's not horizontal. That one is vertical. I haven't yet thought of a very good way to remember vertical, though. Other than vertebrae, which refers to your spine, which kind of stands straight up. I don't know. No, I haven't thought of a good one. Okay, so this is our coordinate grid. We have axes. You would usually label the x-axis and y-axis, and you would also give the graph a title or the grid a title depending on the data, that you are graphing. Right now we don't have any data, so we can just kind of move on. We're going to just create a quick rule that we're going to graph. So let's see the rule. We'll do an additive pattern. So an additive pattern will be one which we're adding the same number each time. Y equals x plus 2.5. Of course we had to throw a decimal in there, right? Come on, it's 5th grade, y'all. All right. So let's make sure that we understand what x and what y are, because it's absolutely essential to understanding what we're doing here. So the x equals the input. The x equals the input. In other words, the number you start with. It's the number that you're starting with, the unchanged number. It's the data that's going in, the data that's going into the function machine. So it's the, the numbers that you're starting with. The y data, on the other hand, if x is input, that means y output. And that is always true. The x is always the input and the y is always the output. That's not something that's going to flip back and forth, okay? We can pretty much bet our lives on it. It's going to be x input, y output. And if I'm wrong, you can come back and tell me in a couple years. So, this is the new number you get after applying the rule to the input, or the x. A lot longer definition, huh? The x, the input, had such a short definition. Y has a much longer definition because it's a more of a complicated concept. The x is just simply the number that's going in. The y is the more complicated number that's going to come out, okay? Because something has to happen to the input to get the output. So we have our rule, which means we can make some input that would go along with that rule. For example, I'll make a horizontal table. That just means a table that's going horizontally. And we divide it in two sections, like that, x and y. And then we just input some data. And sometimes this data is nice and neat, and it goes 0, 1, 2, 3, 4, 5. But it doesn't always do that. Sometimes they throw in random numbers. So it might do something like this. It might be 0 first, then it might be 1, so you might be thinking, oh, well, it's just going to go 0, 1, 2, 3, 4. Not always. Then it might jump to 4, then it might jump to, and then it might just go to the next number 5, and then it might go to 7. You can't bet on what the inputs are going to be, okay? They might jump around. And that's really important because you have to remember to go input to output, input to output, input to output. Don't ever try to apply the rule this way between output to output to output to output. That won't work. That is not effective. So let's start putting in the outputs for our inputs. If I take the 0 here and plugged it into this equation in place of the x, it would be 0 plus 2.5. Well, what is 0 plus 2.5? Yeah, 2.5, right? Okay, so far so good. Now I take the 1 here and plug it in. 1 plus 2.5. Okay, 3.5. Sometimes it helps to say like whole. So like 4 wholes plus 2 wholes and a half. So we've got to remember these wholes. So if this is 2 wholes and that's 4 wholes, then I can just add the wholes together, right? And that's 6 wholes, and then, tack on the little half here. 6.5 wholes, or 6.5. Keep going. Input 5. So that would be 7.5. And then 9.5. So here's where I wanted to warn you about jumping side to side. We see a lot of people that will do this. Oh, look, I see a pattern. Look at the pattern. 2.5 to 3.5, well, that's 1 whole. So it must just be going up by 1 whole each time here. No, look. 2.5 to 3.5, yes, that's 1 whole. But 3.5 to 6.5, that's 3 wholes. And then 6.5 to 7.5, well, that's 1 whole again. And then, look at that, that's 2 wholes from 7.5 to 9.5. It's unreliable. You just can't do it. You can't go from output to output to output to output. It's not reliable. If you go from input to output, input to output, input to output with applying the rule, you'll never make that mistake. You'll never have any mistakes. You'll always get it right, assuming that you added the numbers right. Okay. From this table, we need to pull out our ordered pairs. Thankfully, it's super simple. So if we needed to pull out ordered, that's a weird word to spell for some reason. I got confused. Ordered pairs. Okay. If we needed to pull out ordered pairs, those are the things that just look like this. They have the 2 parentheses, the 2 numbers inside the parentheses with a comma in the middle. Those are what ordered pairs are. So you just match the x and the y together. 0 goes with 2.5. X always comes first and y always comes second. So 0, 2.5. Then the next one would be 1 and 3.5. Those match together. 1 and 3.5. Then the next would be 4 and 6.5. So on and so forth. I'm out of room, so I'm just going to kind of go over here to the side and do it. 5, 7.5, 7, 9.5. Don't mix them up. Don't do the y first. It's always the x first and the y second. So if you have a highlighter, that might be something worth highlighting, right? Showing that the x comes first and the y is always second. Because if you flip-flop them, then you'll mess up your whole graph. Let's go back up to our grid that's lonely chilling up here, and let's complete it. So using these ordered pairs that we just took out, we can complete this grid. You'll notice that we didn't label any numbers on it. That's because you shouldn't label any numbers until you know your data set. Because you might skip by 2s, you might skip by 5s, you might skip by halves. You don't know. You don't know what you need to, increments you need to make until you have your data. Let's look. The highest data for the x-axis will be 7, and the highest data for the y-axis will be 9.5. Okay, that's manageable, right? I think we can just get by with labeling each one 1. Because let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, okay. Actually, we can jump by halves here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. That one, yeah, we definitely just have to go by ones. Because remember, for the y-axis, we have to go to at least 9.5, and I have 10 lines. So I should just label each line worth a single whole. Because if I do any less or more than that, then it wouldn't really make sense. So for the y-axis, each line will be one whole. But see, I counted 14 lines here, and my data only goes up to 7 for the x-axis. And I'm already thinking, oh man, I know a relationship between 7 and 14, right? 7 is half of 14. So that means if I skip a line, like make this a half and make this one whole, skip 2 wholes, skip 3 wholes. Does that make sense? Skip 4 wholes, skip 5 wholes, skip 6 wholes, skip 7 wholes. See how that fit perfectly in there? Now if your graph didn't match my graph, that's okay. You can either add lines to make it match, or you can just count by one wholes. Your graph doesn't have to match my graph, and that's perfectly fine, because regardless, we're going to still be plotting the same data, so we'll still have the same line. Now, looking at our ordered pairs, our first order pair was 0, right here, sorry if you can't see, 0, comma 2.5. The x, this is the x-axis, remember, so that controls how far over I go. So if you go over 0, that means you're not going over any. Like, you're still here at the 0 mark. But then you go up 2.5, it's right there. I know the kids in my class, we've talked about this like a kind of a hotel problem. You have to go over to the elevator before you can go up the elevator. So this is like if you needed to, get to your room, but your room was right at the entrance of the elevator. You wouldn't go over any. You would stay right there and you would just go up. You wouldn't need to go over. Now the next data is, move down a little bit, 1, comma 3.5. So the x data is 1, we need to go over to one whole, up to 3.5. And we know 3.5 is 3.5, so it's going to be halfway between the 3 and the 4. I know you guys knew that, I just needed to remind you. Let's quickly just finish the rest. 4, comma 6.5, over to 4, up to 6.5, right there. See how this data is doing huge jumps? That's perfectly fine though. Over to 5, up to 7.5, and then finally over to 7 and up to 9.5. And look at that beautiful line that it makes right through your data. Do you see how straight? Whoops, my ink was still a little wet. You see how straight that line is? That's how you know that you graphed the data correctly. The ordered pairs, of a rule should graph a straight line. Now this is only when you have like an additive and a multiplicative rule. It doesn't apply when you just have like random data like scatter plot data, or with the size of grasshoppers, or everybody's height, and other kind of sets of data where it's way more random than that. We would never expect that kind of data to go perfectly in a line. That wouldn't make any sense, right? but data that follows a rule, a multiplicative or an additive rule, that will always go in a straight line, which is great, because then you know that if you end up with some funky little dot over here, it's a big red flag, like, I did something wrong, because there shouldn't just be a random dot over here, right? You probably mixed up the X and the Y or something like that. But that's pretty much it for this lesson. I mean, this should all be review. I'm sure you got it. And then, you know, have a good week, and make sure you leave any questions on your Google Classroom assignments. I know you've got a lot this week. It looks like a lot. It's not. Each day is just sectioned out to a different little thing. But if you're ever confused, even if it's just like, how do I make a box on this slide? Please just leave a comment, guys. Leave a private comment, and we can get back to you like ASAP to help you out with all of that stuff, okay? All right. See y'all later.